You got it? Now, let's talk about submerging something that has a very high buoyant force, okay? So, if I took a ball, a hollow sphere, and I submerged it, okay? Let's say that it looked like this, and it was a ball, soccer ball, like this, okay? And let's say it's floating on the water, and I push it under, has a high buoyant force, I let it go, the buoyant force is greater than the weight, and it goes right to the surface. Agreed? Okay. But what happens as I bring it farther and farther down? What happens if I bring it farther and farther down underneath the ocean? What happens to the volume of the ball? It becomes compressed, correct? So what's going to happen to the buoyant force as I bring that ball farther and farther down? It's going to become smaller and smaller, correct? So that it's going to reach a certain point where the weight of the ball is greater than the buoyant force, and it will sink. You get that? So here, the weight is less than the buoyant force, so it's going to go like that. But it gets to a certain point where it gets so compressed, the weight of the fluid that the ball displaces is less than the weight of the ball, and it'll sink. You get that? Mm-hmm. So it's like a little bit of a thought experiment. Here I have a ball floating on the surface. Its buoyant force is significantly greater than its weight, correct? And if I bring it underneath, it's going to shoot up, correct? And not really displace much. The only water that it displaces is equal to its weight, correct? But as I bring it farther and farther down, the volume is going to become compressed, and it's going to displace less fluid. The buoyant force will be less and less and less and less and less. The weight of the ball stays the same, correct? Mass times acceleration due to gravity. But there's a point where this flips, correct? And when that flips, and the weight is greater than the buoyant force, it sinks. Clear? We're done.